Okay, in this video we're going to run through changing the base of a logarithm. Sometimes you're going to find that you have a log with a base that you can't either maybe put it into your calculator, or it just doesn't work with the numbers that you are working with. So it's nice where you can actually change that base to a different base where you can calculate it or compute it in your head or something along those lines. So let's start with our definitions. So if we know that y equals log base b of a, then if we swing this b over, we're going to turn this into an exponential equation, right? We're just going to rewrite this. We know that it's going to be equal to a equals b to the y power. That's just your basic logarithmic and exponential identities. Okay, you can transfer them from one side to the other like that. You can rewrite them that way depending on if you're working out with logarithms or if you're working with exponentials. So knowing that those two things work back and forth, let's look at a equals b to the y power. So I'm going to leave ourselves a little bit of space here, and what I'm going to do is I'm going to say I want to take this equation, a equals b to the y power, and I want to take it to some base. I want to find the log of some base. So I'm just going to put that in there for both sides. You know, just like with any equation, if you do something to one side, you've got to do it to the other. All right, so I've got log base c. C can be anything, whatever we choose to work with our particular function that we're looking at. So log base c of a equals log base c of b to the y power. Now using our properties of logarithms, we can get that y out of the exponent, and we're going to move it over in front of log base c. Now we're going to get y by itself. We're going to divide both sides by log base c of b. These are going to cancel out, and we're left with y equaling log base c of a over log base c of b. Now, we know that log base b of a is the same thing as y, right? We said so at the very beginning. So if we plug that back into our equation, we get log base b of a equals log base c of a log base c of b. And right there, you can start recognizing that we actually changed the base from b to c. And look at how easy this is. Our a's go up into the numerator. So if you got log base b of a, you know whatever your new base is, which will probably be 10, that will be the most common one that we use. But the log of a is going to be up in the numerator, and the b is going to be in the denominator. Really easy. So let's look at an example. If we wanted to change the base of this equation, this function, log 4 of 9, log base 4 of 9. Well, as we just saw with the purple ones down here on the bottom, the 9 goes in the numerator and the 4 goes in the denominator. We'll just use base 10. That's it. That's all it is rewritten. Simple. Let's look at another example. Okay, so this one's a little bit more extensive. If log base x of 3 equals a, log base x of 6 equals b, find log base 3 of 6 in terms of a and b. All right, so what does this mean? This means basically we want to rewrite log base 3 of 6, and we want to only use the terms a and b. All right, so that means we're going to have to change the base to x, log base x. So that way we can use a and b. All right, so log base 3 of 6 is going to change into, the numerator is going to be log base x of 6, the denominator log base x of 3. We know from above that log base 6 of x equals b, log base x of 3 equals a, so we have the actual fraction b over a. So changing bases is much easier than it initially appears once you kind of get into it and fall into the patterns. And that's the way a lot of this is with logarithms. As soon as you get in there and work with them and kind of play with them a little bit, they get a little bit easier and a lot less complicated. So hopefully this helps wrap your head around how to change the base of a logarithm.